let us learn more in detail about magnets. We said that magnets have a magnetic space around it. Now, what is a magnetic field? A magnetic field is the magnetic space around the magnet. Magnets produce a magnetic force called a magnetic field. This field is invisible to our eyes, but iron fillings can be used to show these fields. Now, let us learn how to find out whether a given object is a magnet or not. For instance, think that you have been given three objects of same size, shape and color, and also a bar magnet. Now, if I ask you to decide which one among them is a magnet, which is not a magnet but made of magnetic material, or a non-magnetic material. Now, bring three objects one after the other close to one pole of the bar magnet and observe whether they get attracted, repelled or not attracted. After that, bring those objects close to the other pole of the bar magnet in the same way. Now, first take these three objects, object 1, object 2 and object 3, and observe that whether they are attracted, repelled or not. Now, change observed when you brought one object close to one pole of the bar magnet. First, the object 1 attracted at one pole. Then, object 2 also attracted at one pole, and third object neither attracted nor repelled. Now, coming to the second pole. If you bring the object close to another pole of the bar magnet, at one pole it repelled, object 1, object 2 it got attracted, and third object it neither got attracted nor repelled. Now, what do you conclude by comparing these three recorded observations? From these observations, we can say that if an object is attracted by one pole of the magnet and repelled by its another pole, then you can say that it is a magnet. If an object is attracted by both the poles of a bar magnet and not repelled by any pole, then you can say that it is not a magnet but a magnetic substance. If an object is neither attracted by a magnet or not repelled by a magnet, then you can say that it is not a magnet or a magnetic substance. Now, back in 12th century, scientists they mapped this magnetic field on the surface of a spherical magnet using iron needles. They traced the lines formed by the needles to their points of intersection and called these points poles, making the connection between the two poles of the magnet and the earth poles. Now, we are saying that about iron fillings. Can we separate these iron fillings from soil? Yes. First take a bar magnet and roll it in the soil in your school ground for some time. Pull out the magnet. What do you find? Does anything got attached to the magnet? Yes, you may find some dark particles of soil sticking to the magnet. Now gently remove all these dark particles from the magnet and collect them in a sheet of paper. These are called iron fillings. Now spread some iron fillings uniformly on a sheet of paper. Now place a bar magnet below this sheet. Now what do you observe? Do you observe any change in the pattern of iron filling spread over the sheet? Yes, you will observe that the uniformly spread iron fillings concentrate at two particular points of the paper sheet. At some distance, you will find some scattered iron fillings between these 2 points. This change in the spread of iron fillings on the sheet of paper is due to the magnet present below it. So the iron fillings move towards its ends because of this magnet. The ends of the bar magnet attract more iron fillings than the middle part of the magnet. So by this activity, we can say that every bar magnet always has two ends whose attracting capacity is more than its other parts. These ends are called poles of the magnet. So magnetism either attracts or repels objects, and all the magnets has these two ends, that is a north pole and a south pole. A magnet's poles are the surfaces from which lines of magnetism leave a magnet and reconnect or return to the magnet. So the pole of a magnet is the area that has the greatest magnetic field strength in a given direction. Magnetism either attracts magnetic objects or repels these magnetic objects. If the same poles of two magnets are placed near to each other, they push away and repel. But if two different poles are placed near each other, they attract and pull together. Now, take two similar magnets and place them in four different directions shown here. What do you observe? You can notice that like poles like north-north or south-south of two magnets repel each other, and the unlike poles like north-south attract each other. So unlike poles of two magnets attract each other, whereas like poles repel each other. So the magnets we see in our daily life, they also come in different shapes like bar magnets, horseshoe magnets, spherical magnets and disc magnets. So we have seen bar magnets. It is a rectangular piece made from steel, iron or any other material that shows the property of a permanent magnet. So it has two poles, a north pole and a south pole. If it hangs freely, it always aligns in north-south direction. Its northern pole always faces towards the Earth's magnetic north pole. So these are the weakest type of magnets and are used every day for hanging things on refrigerators or for closing cabinets. Coming to horseshoe magnets, here as the name says, it is shaped like horseshoe or U shape. So it has stronger magnetic field than many others. So by making both the ends of the magnet point in the same direction, the strength of the magnet also doubles basically. They are used to pick up large pieces of metals that are heavy and hard to reach small pieces of metals in construction or engineering. Spherical magnets are sphere in form and are also known as ball magnets. They are widely used in magic hobbies, electronics and many more. And disc magnets are circular magnets that are thin and flat. These are used in markets and industries. So these are the various shapes of magnets that we use in our daily life.